So welcome back. We are now on our fifth lecture, and we are starting on slide number 19 for chapter 2. It says a class completed 500 runs of the iPhone activity using a computer simulation. For each one, they recorded yes if exactly one person got their iPhone. Otherwise, they recorded no. This must be referring to an earlier situation because I don't remember any iPhone questions. But I'm not really so interested in the details of slide 19. I am really, though, interested in the graph on page 20, on slide 20. So even without understanding where this graph is coming from, it's the graph on slide 20 that I want to focus on. Because as we have spoken about previously, what do you notice about the beginning of the graph versus the end of the graph? What's the general, most obvious difference between left-sided graph and right-sided graph?
Stabilization on the right.
Yes, right. Left side, you have a lot of fluctuation, and right side, you have near stabilization. Do you agree with that? In fact, it's fairly stable after, I would say, even 150, 125, somewhere around there. Maybe, I mean, obviously, the more you go, the better. But once you hit 150 or so, it's pretty much fairly constant from then on out, right? Without any major fluctuations away. So certainly after 500, we have a very reliable guesstimate for our value for whatever it is. And again, we don't really care the details, but based upon the graph, what proportion would you say is our reliable, stabilized value that we get from the graph? For whatever the case is. What does it seem to stabilize at? What percentage?
I know you said 150, but
No. What I was just saying, 150 seems to reach stabilization, but use all the data.
35%.
About 35%, it looks like. Maybe 36%, but somewhere around there. Yeah, you don't stop at 150. You go as, use all of your data, right? All of the data indicates all 500. Is it the same result had we stopped at 150? Yeah, approximately so. But you still want to use all the data if you have all the data. Is that correct? Does that make sense? Now, the next slide, slide number 21, shows the last 100 runs. Now, when you really zoom in close, it does not look like it's stabilized because you're zooming in considerably, right? Which just goes to warn you that the amount of zooming that you do can make something look that is stable look unstable, or vice versa. But in this case, let's answer their questions. It says, what was the result on the last run? Was the last run a yes, which would make it go up? Because we're looking for the proportion of yeses for whatever the situation is. Would it go up or go down on the last run? Right? So the last run went down, which makes the answer what?
No.
Oh, the answer was a no. Again, for whatever the situation was, the answer is a no. By about how much did the run change the estimate after the 499th? If we would have stopped at 499 and not gone all the way to 500, what is the difference between the value that we would have ended up with at 499 and the value that we end up with at 500? First, what is the value after the 500ths?
1.
Sorry?
The value?
Yeah, what percentage would be our final guesstimate if we would have gone all the way to 500?
100?
No. Remember.
What percent?
What percent? The left side of the graph lists percents.
Would it be 35.6%?
35.6%. right? 0.356. That's where we end up with at the end, 0.356. Had we stopped at 499, what would have been our guess?
3.57. I mean,
0.357, which is off by 1/1000th, right? It's a tenth of a percent, right? That's a difference, a tenth of a percent, correct? Yes?
Correct.
So even though it looks like it's all over the place, it's only because we zoomed in significantly. Had we not zoomed in significantly, like the first graph, we would have had major stabilization and we would have had no questions, right? In fact, what was the smallest probability amongst these 100 runs? If we would have stopped at any point amongst these 100 runs, what is the smallest guesstimate we would have made based upon the zoomed in values? Look at all the 100 of them and tell me that if I theoretically could have stopped anywhere, what would the smallest guesstimate have been?
0.348.
0.348, which occurs somewhere near the beginning, right? It occurs about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 runs into those last 100. You see it on the bottom left? So if I would have stopped at, if I would have said, you know what, 412 runs is enough, then I would have stopped at 34.8%. What is the largest value amongst all of these runs?
A little over 0.364.
Excellent, a little over 0.364. So what's the difference between 0.348 and 0.364? It's about well, we can do it on the calculator, right? 0.364 minus 0.348. It's off by 1.5%, right? And I think with 1.5%, it's still close enough that, you know, we feel that our answer is accurate. Does that make sense? In other words, even though you zoomed in, we certainly have stabilization. Correct? Okay, so let's now look at, that's all I wanted for this example, basically a little more work with graphs. But slide 23 has a wonderful rule of thumb. You guys know what a rule of thumb is? A rule of thumb is basically a rule that you follow that approximately will give you the right answer most of the time, even though there's no really rigorous theoretical math behind it. It says, according to the law of large numbers, the more runs you do, the closer your estimated probability is likely to be to the theoretical probability, correct? That's why we do lots and lots of runs. In practice, people use statistical software rather than actually doing it themselves. We run simulations, run random number generators, things of that nature. When using software, the person typically continues adding runs until you get stabilization, right? Until more and more runs don't really change anything, okay? In grades K to 8, simulations are often done by hand instead of computers so that students understand what it is that they're doing, okay? How many runs should you do? So it depends. Here's the rule of thumb. Suppose that you want to be off by no more than 1%. Suppose you are willing to accept an uncertainty of 1%. 1% as a decimal is how much? One percent of the decimal is how much? Anyone?
0.01.
0.01, correct? So what you do is you do 1 over 0.01 squared. You do 1 divided by whatever your uncertainty that you're willing to accept is. If you're willing to accept being 1% off from the true value, then what we do is we take 1%, we square it, and then we do 1 over that number. Does that make sense, guys?
It's a little deep, but maybe explain.
Okay, no problem. So again, in this example, we're assuming that we're willing to accept an uncertainty of 1%. So in other words, if the true value is 36%, I'm okay getting anywhere from 35 to 37. 1% this way, 1% that way. In the beginning, we're going to have lots and lots and lots of fluctuation, correct? So the question is, how many runs do I have to go until I've stabilized enough to be within 1% of whatever the true value is? The answer, square that 1% and do 1 over that. So what is 1% squared? What's 0.01 squared? Take out our calculator, let's do it. What is 0.01 squared?
0.0001.
0.01 squared is 0.0001, and then do 1 over that. What do you get?
I got 10,000.
I got 10,000 as well. So the rule of thumb says that if you want to be pretty much guaranteed to be within 1% of the true value, then you'll need to do 10,000 runs. Now, do you want to do 10,000 runs? I don't know anyone who wants to do 10,000 runs. That's a lot of work. But if you don't do 10,000 runs, if you only do, let's say, 100 runs, then how far off might you be according to the rule of thumb? If you do 100 runs, how far off might you be according to the rule of thumb? Who wants to take a guess? A gander, if you will.
100,000?
Well, remember, if you're off by 100,000%, you're not even close, right?
I didn't understand the question.
Oh, okay, that's fine. So if you want to be off by 1%, it takes 10,000 runs.
Right.
We calculated that. What I'm asking now is, what percent might you be off if you only did 100 runs? So let's think about it. What's 10% as a decimal? What is 10% as a decimal?
0.10.
0.1.
0.1 or 0.10. Square that.
You get 1.
No, I don't think so.
0.01.
0.01. And if you do the inverse of that, if you flip it, what do you get?
1%.
I don't think so.
100.
100. If you're not getting that and you're unsure how to use a calculator to get that, let me know and I'll walk you through it. Huh? I don't mind.
Yeah, go for it.
So take out your calculator and do 0.1 squared. Can you do that part? 0.1 squared or 0.1 times 0.1. 0.1 would be the same thing. 0.1 squared or 0.1 times 0.1.
0.01. That's what I got.
So you get 0.01.
Yep.
Now there should be a button on your calculator that looks like this.
-1?
Yeah, I got a negative exponent, but
Yes. So hit that
then
and then hit enter. Or equals, whatever your calculator is. It should, if you do it,
10.
it should give you 100.
Yes.
Oh, I'm sorry. I did this.
Does that make sense?
Yes.
Of the practice.
Sorry?
Of the practice.
Of course. That's why we do this. Of course we practice, right?
Okay, so you said to square
So
point
square,
one, right?
square, yeah. If you want to be off, if you're willing to accept being off by 10%, you take 10%, you square it, and you invert it. You do 1 over that.
Okay,
That'll give you how many runs you need to be certain of being that close.
Oh, okay, got it, got it. Thank
Right?
you.
So 100 runs, and I know that I'll be within 10%. 10,000 runs, and I know I'll be within 1%. So obviously, the more runs that you do, the closer you'll be to the true value. Does that make sense? So let's look at the last question on the page. It says, national polls often want to be highly confident of estimating proportions to within 0.03 or 3%. If they want to be within 3%, about what sample size should they use? So do the same thing. Take your 3%, square it, and invert it. Take your 3%, square it, and invert it.
Would it be 1,111 point and then 1 dot dot dot?
Right. Now, you obviously cannot ask 1,111.11111 people. So we have to round, correct? It's got to be a whole number. Do we round down or do we round up?
You round up.
You always round up. Even though it's closer to down, we're looking for the minimum number of people we need to ask to be guaranteed to be within 3%. If we round down, we're no longer guaranteed that. If you round up, it's even better. You'll be even closer than 3%. So even though it's closer to 1111, we always round up, and the answer will be 1112. According to this, huh?
Will it be a percent?
No, we're looking for how many people we have to ask,
Okay.
right? How many runs we have to do.
Okay.
So the answer is going to be a number, like a whole number. You have a question? You have a confused look on your face, Yesenia.
Could you go through those steps again, please?
Because you said that we have to square 0.03, which is 3%, right?
Right, so you square 0.03, and then and then you invert it.
I don't get any of that.
Well, what do you get when you get 0.03 squared?
0.03 square. I get 0.0009.
Now do that to the -1 power.
Ouch.
My calculator showing it's an error.
So tell me what you put in. Whoever just said that, tell me what you put in.
0.03 to the second power.
And you hit enter.
Yes.
Now what do you see when you have that?
Look, I'll show you right now.
Okay.
Hold on. 0.03 to the second power. It goes. It says 9.
Yeah, wonderful. Right, wonderful. Now do that to the -1 power. Just hit X to the -1. Don't type anything else. Just hit X to the -1.
Oh, I see it.
And that's your answer.
Okay. And then you just round it to, so it'd be 1. You want 3 numbers? So
Well, no, I want the whole number.
okay, so it'll be 1,112.
Correct.
Okay, I got it.
Okay. Laura, do you still have a question?
I think I got as far as the 0.09. If we can just do it one more time, because this is new, this calculator.
Yeah. So what you do is you take 0.03 and you square it. You should have 0.009.
0.03 squared, 0.03 squared, enter.
And then you do
9, -4.
9e -4, correct?
Yeah.
If you don't like that notation, that just means we got to change it to a better notation.
Okay.
Because that notation is a scientific notation.
Right.
So if you
Which
don't
just
like,
means it's to the right of the decimal, correct? No.
not it.
With
Yeah,
the zeros.
yeah, but it's three zeros.
Yeah, 3 place values that are to
Right.
the right.
But it says -4, so some people are a little confused with how many zeros. Like Why is it 3 zeros if it's 10 to the negative 4? That kind of thing. But if you understand it, that's fine.
Okay,
Either way,
I
Yeah,
just
go
didn't
ahead.
know after that then.
so hit X to the negative 1. There's a button X. It should be X to the negative 1 if you had my calculator.
Yeah, I have that calculator.
Okay.
But now I must have did something wrong because I got a whole bunch of ones, like 1, 1, 1,
No, that's what you want.
There's
1, 1,
nothing
1,
wrong.
1. That's the answer.
1. Okay. Oh, and then you round it up.
And then you round it up to 1.
Sorry.
And then you
Okay.
round it up to 1, 1, 1, 2. That's
Okay,
exactly.
got it.
I still don't get those numbers, those 111s.
You don't get it?
No, I don't. And I don't have that times -1.
Okay, so tell me what you have on your calculator when you do this.
This is what I have. I don't know if you can
Okay.
see it. I actually haven't put a battery into my scientific calculator.
Okay.
So I'm using my phone. So this is what I have.
Okay.
I don't know if you can see that.
Okay, and now do it to the negative 1 power. You should be able to do that. Hit to the negative 1 power.
You have to tell me what it looks like. 'Cause I have no idea.
It should look like.
What?
Is that me or is that someone else?
You have to hit X, Y, and then put 1, and then you can change it to a negative on your phone.
X, Y, and 1.
So you should have a button that says X to the Y power. Do you see that? Something that says X to the Y power or Y to the X power?
Yes.
Maybe?
I see the X, Y.
Okay, so hit that.
Okay. Okay.
Okay, so what you have now, hit negative 1.
So X, Y, 1.
And it should say the answer, no?
No, I'll figure it out on my scientific calculator. It's fine.
Okay,
Using my phone too, and it's the 1/x, and it should give you that answer.
1/X. Okay.
Yes, hit that one after you hit everything else.
oh, you have the 1/X button. The 1/X button should be fine too. Is it?
And once you hit it, it gives you 1,111.1111, whatever.
And that's what we're looking for.
This is that what you're looking for?
Yes, that's exactly it. And then what we got to do then is we have to round it,
Okay.
right? Because what we want is a whole number, and it has to be bigger than whatever we got when we approximated.
Thanks everyone for the help.
Does that make sense?
Yes, thank you.
Okay. Are there any other questions on this?
No.
That sounds reasonable?
Yes.
Okay, so what we're gonna do now is start the next, I mean, what time is it? Maybe we'll just do the quiz now. Maybe we should do the quiz now, give you guys time. And then as soon as you finish it, let you guys go. What do you think?
Oh, nice.
That seem okay?
Yeah.
Okay, so since there were no questions on the quiz, I guess I'll just ask a quiz question, and that way everyone should be able to do amazing on it. What do you guys think of that idea?
Sounds good.
Okay, so which quiz question should I ask? Which homework?
You're asking us what question from homework number 1?
Yeah.
Number 1.
Giving you guys the number 1. That's too easy. You know what we're gonna do? We're gonna do
Number
we'll do number 2 because people ask me that number 2 in class.
All right.
That's a pig question, right?
Yeah.
Yeah.
Okay, so we're gonna do the pig question. That's gonna be the quiz. And you don't have to be on camera. What I want you to do is I want you to do it, and then I want you to take a picture with your phone, and then I just want you to email me that picture. Can you do that?
You want an email or send it through Canvas?
Either way, as long as it gets to me, it's fine.
So you just want number 2 with the graph, you want 3 with A and B?
The whole number 2. It had multiple parts, correct?
It had A.
It has A, B, and C.
Yeah, so the whole thing.
Okay.
So if we did it, we just take a picture and submit it to you?
Well, that's what I want you to do. But if you did it for homework, don't just send me your homework. It's great that you did it for homework, but I want you to do it now. And I'm trusting you not to use my solutions,
Okay.
not to use your solutions, but to do it as if you haven't seen it before.
Okay, so I'm gonna go print out a clean copy then.
Okay, that's what I'm trusting you guys right now.
All right, I'll be right back.
Okay, you guys don't have to. You can leave the room now. You have to the end of class. So just email to me before 3:15.
Okay, all right, Professor. Have a good one. We'll see you out there.
Everyone?
Good,
I'll see you guys-
Professor,
Thank
Yes.
you.
it's just using the same numbers, but we're just gonna work through the problem is basically what you're saying.
Correct.
Okay.
Just do it again.
Okay, thank you.
Okay, guys?
Professor.
Okay. Yes, your question, ask. Yes?
Since I asked you for the under 10 thing and I forgot to do it myself, how much longer can I do just in
You
case I
can
needed
take
more
it.
time?
You can take as much time as you want.
All right, thanks.
Okay?
Also, I had another question. So did you
Yes.
get my email about the notes or whatever beforehand?
I will check right now.
All right,
I will check right now, okay? You can do it online, paperwork, printed, that's fine either way.
got it.
Sorry, it cut off whenever you were telling us. Do we email it to you or?
Yeah, you can either email it or send it via Canvas. I'm okay with either one.
Okay, thank you.
Okay?
Professor, I have
Yes.
a question. Next week, Thursday, do we have a quiz?
Next week, Thursday?
Yeah.
Next week, Thursday, we might. Why? Are you not going to be here?
At 2:45, my son has a doctor's appointment.
Okay, well, if worst case scenario, we'll figure it out. Let's not worry about it right now.
Okay.
I can't think that far ahead.
Oh, okay.
Okay, I can't even think a minute ahead. So so we'll worry about that. Okay?
Should I contact you next week, Wednesday, email?
No. I'm saying if I end up scheduling one, then we'll worry about it then.
Okay. Perfect.
Sound good?
Bye. Yeah.
Okay.
Perfect.
All right. Bye.
Professor, only
Yes.
because I was distracted by my stupid phone.
Yeah.
We are supposed to send a picture of number 2, ABC, to you, completed. What if we already did it?
Well, you should have already done it because it was homework, right? The point is
Yes.
not to look at your homework, not to look at my solutions,
Oh, got you.
and to redo it.
Got you. And then we come back.
And
is this it?
no, class is over. Class
Okay. Okay.
Okay.
It
So you
threw me
can-
off.
Okay.
Thank you.
You're welcome. You can go if you want. You don't have to stay.
My bad, I'm sorry.
Okay. I'll just wait till everyone goes, but you can go. And you can go too.
Sorry, one last question. So
Yes.
it should be page like 16 and 17, right?
It should be, let's see. I don't have it in front of me. But it should be the pig question. Question 2.
Oh, just question 1?
Question 2, I thought.
Oh, question 2, a student rolled a pig 20
Yeah,
times.
that's the one.
Because question 1 is pig tossed 30 times.
Yeah, no, that's
Oh,
question.
but you want question 2. Okay,
I want question
thanks.
2. Okay.
All right, thanks.
Okay, no problem. See you later. Okay, bye.